Geneva, Switzerland, home to the United Nations, World Health Organization, Red Cross, and CERN, the European Organization for Particle Physics. 100 meters below the French-Swiss countryside, stretching from the Geneva airport to the Jura Mountains, lies a 27-kilometer-long tunnel, housing the Large Hadron Collider. Inside the tunnel, protons are accelerated to nearly the speed of light by strong electric fields, guided by superconducting magnets and made to collide at 4 different locations. The ATLAS detector sits at one of these locations, where it observes and analyzes the new particles produced in the collisions. It is composed of several specialized layers, each used to identify particles and to measure their properties. Here, at the heart of the collision, is where the mystery lies. The discoveries made in ATLAS will answer some of our most fundamental questions. Why do particles have mass? What are the fundamental building blocks of nature, and how do they interact? And is there one theory that describes everything? The construction of the ATLAS detector is an impressive achievement by an international collaboration over the span of 18 years. Scientists and engineers came together to contribute to the design and construction of the experiment, as well as to the development of the software and the computing required to run the detector and analyze its data. The various components of the detector were constructed all over the world, then shipped to CERN, assembled, tested, and lowered into the ATLAS cavern one by one. In a little over 5 years, the entire detector was assembled in this manner, much like a ship in a bottle. Here we see the assembly of one of the 8 ATLAS superconducting toroid magnets. Each 100-ton magnet coil was lowered individually through the shaft and then assembled to define the characteristic size and shape of ATLAS. The central components of the detector were assembled individually and then slid inside the magnet structure. They include calorimeters to measure energy and, at the very center, a tracking system designed like a precision camera to take high-definition images of the tracks of charged particles. If the detector were a camera, it would be a 100-megapixel device capable of taking 40 million photos per second. This giant wheel, located on the far end of ATLAS, is more than 6 stories tall and is the largest single piece in the cavern. It completely closes the end of the detector so that absolutely no remnants of the collisions can get out undetected. Despite its enormous size, the positions of its internal components are known as accurately as the thickness of a few human hairs. The completed ATLAS detector is 27 meters in diameter, 46 meters in length, and weighs 7,000 tons. That's equivalent to the weight of the Eiffel Tower in Paris. Here we see a piece of shielding being lowered down an Atlas access shaft. This strong tube encircles the beam pipe inside which the collisions occur, and is designed to maintain the integrity of the beam and to protect the sensitive components of the detector near the beam line. This is the last stage of preparation before closing up the cavern and turning on the accelerator. Once the cavern is closed, an electronic system prevents anyone from entering the cavern while there is beam in the LHC. "93 meters above the detector floor, physicists in the Atlas control room prepare the detector for the injection of beam. In operation, the LHC collides up to 40 million bunches of protons together every second at the very center of the detector. As particles produced in these collisions fly through the detector, they leave traces that are read out by electronics at nearly 1 million gigabytes per second. A complex system of electronics and fast software is then used to filter the data, selecting only those collisions that contain interesting and potentially new and exciting physics. Today, 3,000 scientists from 175 institutions in 38 countries around the world are actively analyzing the collisions produced by the LHC and measured in the Atlas detector. Like a powerful telescope that peers far into the heavens, Atlas is able to explore the internal universe and to examine our most fundamental components. Only by exploring this new frontier can we find answers to the most fundamental questions of mankind. What is the universe made of? What are the rules that govern its evolution? What are its origins? And what is its destiny?